Mr. Durai Ganesh is the founder and CEO of Quantum Research Labs and co-founder of Quantum Computing India, Bangalore. He's currently working as Chief Quantum Architect at BosonQ Private Limited, Bangalore. He is also currently pursuing Executive General Management Program from IIM Bangalore and has previously worked at multiple national and multinational companies. His expertise lies in quantum computing, deep learning, LLMs, and generative AI. With this, I would like to invite Mr. Durai Ganesh for his talk on architecture for quantum-inspired solutions.
Hi, sure. Thank you. Thanks, Ashish, for the nice introduction. My camera is not activated. I don't know whether it is you have to activate that one.
I think it's already activated. So could you please share your screen?
Let me share my screen.
I think your camera is already on. Yeah, it's already on from my side.
Yeah. You see here.
Oh, from my side, it's already activated. For some reasons, it's
maybe it is the web browser, so permissions might not be given. Can you please check?
Maybe it's maybe because of the web browser, I believe. Yeah.
Let me check the browser permission.
Or maybe rejoining.
Because it asked me to enable, and I allowed those things. Okay. In the interest of time, I think it is okay. I think, is it okay if I can continue without camera also?
Yeah, sure. Could you please share your screen?
Yeah. Hope you are seeing my screen now, right?
Yeah.
So let me start the deck and I will start explaining. So, hi all. Good evening, and thanks for joining on a Saturday evening, and for some it may be Saturday morning. Welcome. This is a short session on architecture for quantum inspired algorithms. So whenever we are thinking about the quantum solutions, mostly we were targeting IBM Quantum 1 or Amazon Bracket or Google Sycamore or latest one Willow, or these kind of QPUs, quantum processing units mostly. Before running on them, what we will do, we will use any of the simulator, Qiskit, Cirq, Penny Bracket, or Microsoft QDK. So there are many simulators. So most of the quantum solutions as of now are built based on quantum algorithm. We are assuming that it is going to run on a real quantum computer or quantum simulator. But all of us know very well the quantum hardware is not sufficient enough. It is the number of qubits are increasing, error rates are decreasing. We are in the first generation of quantum computing. But industry is expecting the solution yesterday. Am I right? So most of you who are working in industry, you know that industry is expecting solution yesterday. So now quantum solutions are really great because they have a strong mathematical model promising a natively parallel execution of NP hard problems, and they are promising accurate output for many use cases. But I have to wait at least for the next 3 years or 4 years to get a powerful quantum computers with a reasonable number of logical qubits or physical qubits with less error. That is where the quantum inspired platform are come into picture. If it is first time you are hearing, I would like to show these 3 screenshots. Actually, the first 3 dots are from Microsoft Azure marketplace, where you can see there is a anomaly detection using Azure Quantum from Emphasis, which is quantum inspired optimization. And you can see that the rate is in INR. This is the cost per month. So very low, right? Reasonable price. And there is another Azure application provided by Toshiba called SQBM. for Azure Business Standard model, and there is a development model. But these three things are from Microsoft. So I wanted to show you the Toshiba website also. If you go to Toshiba website, I have shared all the URLs. If you go to Toshiba website, SQBM page, you can they have a detailed explanation what is SQBM, what they can do. And similarly, Fujitsu also has a digital annealer. All these things are proving that there is a production ready quantum inspired platforms, which means if you are planning to build a quantum algorithm, but it cannot be executed or it cannot be released as a production solution due to unavailability of high quality, high volume qubits, the alternative approach is trying to tweak your algorithm such that they are running on a quantum inspired platform. So what are these quantum inspired platforms? They are basically classical systems. You see here, quantum inspired algorithms, they are basically classical systems only, but they are using a quantum approach, or the operations are based on concepts like superposition, entanglement, and interference. If we recall, our classical algorithms are based on Boolean algebra, on binary numbers, and we are building most of our solutions based on Boolean algebra, whereas quantum is promising linear algebra on complex numbers. So if you are able to tweak your algorithm, say for example a neural network hidden layer which is using binary matrices in the case of classical systems, can be tweaked such that they are using rotational gates with entanglement. So that rotational gate and entanglement will run on quantum hardware only. But how can I run it on the classical? So build a classical simulator or a classical library which is using this complex number, linear algebra, and Hilbert spaces, in which will execute your classical algorithm but using superposition, entanglement, interference for its hidden layer of neural network. So whatever I'm telling now, it may look like is it possible to do that one? But it is absolutely possible. All of us know we can write our own linear algebra library. If you are good at good HPC coding with strong foundation C, C++, low level programming for higher performance matrix manipulations, you can build your own linear algebra which is able to process complex numbers rather than a binary number. Obviously, since it is a classical hardware, internally there will be a layer which is encoding or converting your complex number into binary. Then your simulator will execute, then it will return the output. So this is promising. Since classical systems are matured, we can build very powerful quantum inspired algorithms which are going to run on quantum inspired platforms like QIO from Microsoft, SQBM Plus from Toshiba, Digital Annealer from Fujitsu. Like that, there are many other are there, but these are all at least available now to my knowledge. Maybe there may be new products may come, and if right people join together, we can build our own quantum inspired algorithm also. I have a plan for certain operations. You can consider this as an open invitation. We can build our own simulator for running quantum inspired algorithm. Then obviously now you are getting interested. Actually, what are those layers in a quantum inspired algorithm? There should be a problem definition layer, then algorithm layer, execution, hardware. So we are going to see what are those 4 layers in clearly. So the problem definition layer will define your problem, any combinatorial problem, mostly combinatorial problems are solved using quantum inspired algorithms. So obviously they are NP-hard problems. So any NP-hard problem which falls under combinatorial, which will explode as a exponential growth, those problems should be converted into, or I would like reformulated into, a quantum approach. In classical, we will use TSP using a popular data structure algorithm, data structured algorithm. They have a lot of algorithms, breadth first, depth first. There are many classical algorithms which are using linked list or stack or queue, those kind of structures. But here, what we have to use, we have to think about our algorithm using, sorry, I'm going fast, using superposition, entanglement, and tunneling. These approaches need to be utilized in the problem definition, meaning that actually it is mathematical model building, a theoretical work. After that, we have to model that, or we have to implement an algorithm for the mathematical model which built in the problem definition layer. This is the crucial part, because here we have multiple workload. We can run our algorithm in different models. All are quantum inspired. The first one may be quantum annealing, which I discussed now. Then other one is quantum inspired evolutionary algorithm. Then quantum inspired neural network, variational quantum inspired algorithm. These are the techniques, and now these are all can be built into one simple platform or one single platform, or there may be different platforms, and these are all futuristic idea. Currently, quantum annealing inspired algorithms are realized. These things are still in the research stage. So you cannot see a production ready platform for evolutionary algorithm or quantum inspired neural networks. There are many papers are there. I have gone through them, and it is really promising. And actually there is one TSP problem, optimization problem also, but still. And then execution layer, obviously it will use, see, actually the TensorFlow Quantum, Qiskit AR, these are all the plugins which are connecting, but predominantly execution layer is a classical wrapper around these quantum simulators. Then comes hardware. The hardware is GPU, TPU, FGAs, and neuromorphic chips are still under research. They are not, there is no any production system based on these things, but I have seen in my network few people are using FPGA also. I cannot share who are the organization are working on those things, but I have seen FPGAs are explored for building quantum inspired algorithm. I personally built a simple simulator to run on a Raspberry Pi, just a few quantum gate operations, single qubit and superposition, but I'm not able to move to entanglement multi-qubit due to time limitations. So what I want to convey, it is feasible to build a simulator on a classical hardware to execute quantum algorithms. That's what I want to convey under this hardware layer. After that, here is a summary. In the interest of time, I'm going slides. I'm not giving, I'm not allowing to ask question now, but feel free to paste your questions in the chat window, because I'm going to finish in few minutes, then answer your questions. Then the workflow, usually how we will build a workflow: first encode the problem, then try to reformulate your problem into quantum behaviors, then use a variational approach or hybrid approach. Obviously this is in classical also we are using VQC, in pure quantum also we are using VQC architecture, a quantum for computation and classical algorithm for optimizing. Same thing we have to follow here also, because always we can leverage the power of classical systems. At the end of the day, classical systems are very good at optimization of your result, not the actual optimization, because the actual optimization will be done by our either quantum systems or quantum inspired algorithm. The result using feed forward or back propagation or any other loss function, cost function, using those approaches we can tweak the parameter and then run again. That portion classical are good. Make use of that, leverage the power of classical. Then obviously we have to interpret the solution, then make output, visualization, result. This is the standard workflow. Only the second step involves little bit a smart way of employing quantum behaviors in classical mathematical objects. A superposition need to be implemented as a classical binary operations. Maybe that is where we need more memory, because all possible probabilities need to be encoded into the number of qubits. Here is the challenge, where the qubit number of qubit, as number of qubit increases, the 2 power n probabilities and 2 power n states will cause the memory requirement grow exponentially. That is where HPC cluster coming into picture, because vertical scaling is not possible. Horizontal scaling will not give the performance. Obviously we will switch over to a proven technique, HPC, which is using GPUs, TPUs. Hope I'm making sense now. Let us move on to a simple optimization problem, how it is done. In this quantum inspired algorithm, as of now, we are focusing, it is like D-wave annihilers. Why we are using D-wave annihiler? Because D-wave annihiler good dot local minima we are using for optimization problem. Like that, as of now, quantum inspired architectures are predominantly used for QUBO and Ising model problems, exclusively for optimization problems. So you can choose any one of these models: simulated annealing or parallel tempering or population annealing. And for your information, simulated annealing is realized now. Parallel tempering, population annealing still in research. So they are not available as the production quality system. Then obviously this one I put it how Microsoft QAO is working. So obviously it is Azure Quantum. Here is a simple program also, a sample program to give you the confidence. Yes, this is a good model. Only thing is you should ready to spend 4 lakhs per annum if you are using, sorry, per month. Sorry. If you are planning to use Microsoft Quantum Inspired Optimizer, which is the emphasis system, you have to pay 4 lakhs. Then comes interpret. I leave it because we know already. And the application is predominantly in one class of problems which can be classified as QUBO and optimization problems or combinatorial problems in the broader sense. And here is the comparison of those 3 things whatever I have discussed earlier, because this, as of now, these are all available now. You see the last option, we don't need hardware. That is a kind of, oh my god, I need not to limit it by qubit count. See, you may experience this one, right? You build a beautiful model, it is working fine, and when you demonstrate that one, of the potential client or potential evaluator, okay, why the accuracy is very less? Obviously classical systems will outperform your quantum model. It is what happening in all machine learning model or optimization model. Whatever you build quantum algorithm now, when you benchmark that is where we are facing the challenge. See, already we are facing this lot of challenge in implementing our classical problem into quantum, but the outside industry, I call it like Harry Potter muggles. Those who don't understand quantum, they will simply ask the question, hey, your model is not performing. The comparatively state of the art classical is performing very, very good. it is giving 96% accuracy, but your model is giving only 82 or 75. How can I utilize your quantum algorithm? Yeah, it is as of 2024 we have only few thousand qubits. We need 40,000 qubits. Then they will ask the question, when will you get the 40,000 qubits? But the quantum inspired platforms are promising, hey, you can start using your quantum inspired algorithms and models day one. That is the promise. That's why I'm exploring quantum inspired platforms and algorithms for my certain researchers, and that's why I want to spread the word. Hi team, here is one platform which is classical, but the mathematical models are based on quantum operations, and there are products available from respected organizations like Microsoft, Toshiba, Fujitsu. Why don't you explore that? This is what my session. I am ready to answer your question.
Yeah. Thank you so much for the great presentation. There are two questions actually. So somebody is saying that if we have a classical analogy of the same algorithm and implement that on classical hardware, and if we use this quantum inspired algorithms, then what benefit actually it gives is what somebody is asking.
Very interesting question.
Yeah.
And this is already implemented as a classical solution. Then why we have to reinvent the wheel? That is the question. If I want to rephrase your question, since there is a classical implementation, why do you reinvent the wheel, convert that into a quantum algorithm, then run it again on a classical system? Correct? That is a very valid question. Here the trick comes with the capability of superposition, entanglement, and interference. Advantage of this one is, when you build the model, the operations will give you better execution time or reduced execution time because of the entanglement behavior and superposition behavior. Remember the word I told you, 2 power n probabilities along with 2 power n states. And now you built as a quantum inspired solution. Take example, I built one combinatorial problem. A quantum inspired algorithm is running for 4 minutes. A pure classical algorithm is running for 3.5 minutes. So only 30 seconds I'm getting advantage out of my quantum inspired algorithm. KG, what is the use? Now think about this one. This quantum inspired algorithm in 2028 or 2029, when we have 7,500 logical qubits, we can immediately port to this application there, and they are literally quantum ready. Only thing, we have to change the line for target system. Currently target system may be QIO from Microsoft or SQBM from Toshiba or Digital Annealer from Fujitsu. But when IBM quantum system has 7,500 logical qubits, no error. This model can be immediately run on that one, just changing the plugin. Now we are gaining the quantum algorithm. So this is also a futuristic algorithm, but my observation when I'm using quantum inspired platforms, they are really giving a better performance. I would say more than 30% of performance we can achieve using quantum inspired architecture. Second question. What is the second question? Does it answer your question?
Yeah, the second question is about the Arduino hardware. Somebody is asking, can I do this on Arduino hardware?
Okay, I did on Raspberry Pi. Obviously Arduino also you can do, but only make sure that the linear algebra, you have to build your own linear algebra library such that it can handle the complex numbers and quantum gate operations. It is technically possible, but the promising approach, what I would recommend, explore FPGA rather than Arduino. There is a reason. Arduino, whatever you do, whatever fine tune, they cannot be scaled vertically. Only thing you can scale them horizontally. So my recommendation is focus on FPGA. Whatever effort you are going to do it in Arduino, please put it on FGA rather than Arduino. That's why I stopped my efforts on Raspberry Pi, then moved to quantum inspired algorithms on the HPC clusters. Hope that answered your question.
Yeah, I think it answered his question. I do have one question. So yeah, if I have to, do it on FPGA, so is there any, like you said, you can't, speak out the names of the people whom you know that who are working on FPGA. So apart from that, do we have any references for that? If anything was implemented?
Please contact me one-on-one. I will directly connect with those people because they also asked for resources for FPGA. So feel free to connect with me. Shah can share my contact number. Please connect with me. I will connect you with the right people.
Yeah, sure.
Indeed, industry is looking for people who are ready to explore QIA on FPGA. So it is an immediate market.
Yeah. It's great to know. And Sahit has one following question. So
please.
He's saying the main benefit will feel only when we have quantum computers, but this question is already answered by you, I guess. 30% gain.
That's what I wanted to know. The main benefit, at least since I am in the industry, I am reaping now.
Yeah.
So we need not wait for quantum computing. That is the advantage of quantum inspired algorithms. That's why when Shah contacted, I told Shah, we have to talk about this one. We have to spread this news to the world.
Exactly.
Yeah, exactly.
Your session is also wonderful. The flow is
Thanks,
so good that anybody can understand easily.
Thank you, Mr.
Thanks for the opportunity.
Thank you for the wonderful talk.
Thank you. Have a great day. Bye-bye.